Is my screen visible now?
Yes.
Okay, let's get started. Uh, Morning we saw that we had session on block segment. Now we will go through the three services which includes that concludes the digitization pipeline. First, we'll start with the version one of document digitization, which is only Google Vision API using, and the next version 1.5, where we'll see the conclusion of all the digitization pipeline, including Word, layout, block segmenter, and Google Vision. And 2.0, the same process. Instead of Google Vision, here we'll be using the Tesseract pipeline. Okay. There is this sample document which has already been created, but it's outdated one. Uh, Please update this one also. Okay. So if in developer's account, we just log into any one of the annotators account, uh, you will get you'll get some three versions as I shown you previously. As I showed you previously in the digitization form, you'll get some version one using only Google Vision, version 1.5 using all the digitization macro services, and version 2.0 for which one? Uh, Using Tesseract. I'll show you the output of 1.0 also, which is using only Google Vision API. Google Vision API in the sense it has only file converter, Google Vision API, then OCR tokenizer. That's all. This pipeline extracts text from what you can say images, scanned or digital document, anything. But when extracting the Google Vision service, whatever it's written, it will extract the PDF into images. Then Google Vision API will be called for OCR, and it will be shown. It's very simple, just a small digitization process. It will not take anything much more than that. It won't have any layout detection or table detection or word recognition or anything. Just straight away Google API. Okay. See, I think it's already been removed. Okay. Nonetheless, I'll show in local itself. This has been removed. So by the way, this service, Google Vision API, which 1.0, whatever we are using, the service name is called GV Document Digitization. It's an ETL Anuvaad document processor, and under document processor, GB document digitization is the service where we are running the this one. Let's get back to code once. Same procedure in document digitization, responses, service as process input. This document digitization can process a JSON file also. If you have any layout or a block segmenter or word detector JSON, you can pass a JSON also. Else, you can pass PDF also directly. It's a standalone service which can be used anywhere else. Okay. Let's go to doc preprocessing. When the document has been initiated, so you need to have a document, I mean a PDF document. So PDF document you should have, and if you initiate that, so it will directly come into doc preprocessing path. First, it will check for if there is a JSON file. It will check for that in file.kc if it is a JSON file. If it is not a JSON file, then it will run the doc preprocessing file, wherein in doc preprocessing file we will create the PDF processing data. This particular piece of code is same across the OCR services. like in word editor also, and in block merger also, and in here GUI document digitization also. This piece of code works around all these services in the same. Okay, first we'll create the PDF processing paths. So wherein we will create a directory with UUID with respect to that file name underscore one UUID. So we'll create that directory. Under that directory, we are gonna what you can say, uh, put all the images whatever we are using here in this G documentation processing in this directory. Once the directory has been created, now we'll extract the PDF data. What we'll do first, we will extract all the images paths using PDF to HTML tool. So inside the directory PDF to image, uh, we, we are converting first PDF to images from the path, not the HTML. We'll convert the paths and we are keep the DPAS 200 here, and uh, uh, UUID generator for each images, which in turn it should be a UUID. Once the PDF to images has been converted, and it will be stored in the specified path, where this one specified path where previously the PDF directory which it got created. So after the processing, next we'll go to text extraction. In text extraction, keep in mind that you need to import couple of Google APIs, which is mentioned here in the requirements. So you have to install couple of Google API for Python client and Google Auth and Google Vision API for using the Google Cloud Vision API. So once you get that, you'll have the respective access and text extraction. So wherever you are specifying the clients and uh, text annotation or break types in Google Vision, so just make sure that you specify with environment variable Google underscore application credentials and give the respective JSON path. Okay. In server, this is an environment variable which will be called directly for this particular service, even in OCR GV server also. Here, just for purpose, I'm running in local. I've specified here itself. Okay, saying that this is an environment variable Google application credentials, wherein this is the file. This is the production file wherein it uses Google Vision API. So it's like a SSH file or a secret file, PEM file, what we will use to log into server now. Is that access file. Okay. Without this one, your Google Vision will not run. So you should have that. So you can initially create a separate Google Vision or this secret files with your accounts. So first 150 million of textual data lines, whatever in the images, is free for users. After that, they'll charge uh, for each 100 or 500 million, just zero point 0.5 or $0.25. That's all, not more than that. So currently, what we get on a monthly basis for Google Vision is approximately around, if at each environment, it's 100 to 300 rupees. That's all, not more than that. Okay. So after that, next, once the images has been extracted, the initialization has been done for Google. Now let's get back to this one. The get text functionality has two things. First, it will read the images. Say that if we are specifying clean background here, currently it's specified to false. I think GB document digitation is set to be false for now. Okay. First, it will read the images. So it will check for the path. If the images, if the image color is less than 175, I mean, if there is no black, it will just remove all the uh, black images and make it as a masked images, watermark images. So let's say like you have a watermark images of any other colors. Okay, it will just check for that black pixels around. It will just make it as white all over around, and it will only just save it as watermark.jpg, just for watermark, showing of watermark purpose. Okay. Else, the mask path, it will be saved as the path whatever it's the image is being read on. Okay. So currently, this one is made it as false in the version 1. Okay. So after that, we will read the mask images. Why? Because so we don't want any watermark here and there. So after cleaning that, so we will read that image. So we will call the vision API. So vision.types.image is the content where it will read. Document text detection is where it will detect text and give the responses. Okay. So once the response is given out for each and every for each page, we will make the uh, it will send out in a tuple saying that okay, these are the regions, para lines and words, whatever you are seeing in the output structure of a digitization flow is the same what Google is also sending. Okay, we are following the same thing and we are also making the same structure in Tesseract also. Okay, once that is done, in get document bonds, we will align with uh, for each and every block per page, we will align with one identifier called UUID and bounding box. And the first one is with respect to the classes called para. Okay, and after that we will append each and every box of each and every blocks bounding box data whatever we have got from Google Vision into one JSON format. Okay. After that, in that whatever we have extracted, so we will post process reserve things, extract lines wherein if it will see the bounding boxes, it will specify if there is any uh, uh, anything more than it's going out of line. We will in that particular paragraph, we'll extract those particular lines and we'll make it as one lines. I mean here it is calling all the specifications like checking of spaces or extra spaces which is sent by Google Vision. We will omit all those things and we will just send it back. Okay, okay, got it. Okay, so you can just go through all these functionalities, and afterwards just text and get text. Second, talk processing, view documentation, text extraction. Okay, I directly went into detection of getting of this text detection. I didn't tell you the pre-process of this particular files. So before sending into Google Vision, we'll do one round of pre-process. So it's called we will check the orientation of that particular image. If the image is being tilted at any angles, I mean, greater than 2 degrees, so we will check with image orientation. Okay, so image orientation is also added here. So if this config.align is made true, the image orientation will start working. How it will be work? So here we are using two things. One is how transform line detection, and another one is uh, east pre-trained model for detecting the orientation correction. So I think there is one document here where a detector called orientation correction. Just go through this PDF. So wherein if there is a tilted images like this, it will it will tilt back to straight format, because when you are doing a OCR, so you always need a straight images. If there is any vertical or any if there is any horizontal tilted images or slanted images, you won't be uh, able to work around with that. So there is still a obstacle in detecting slant images. So if you're looking at an image, it should look the text should look like straight horizontal way. Okay, it should not be in a vertical way. Okay, it should be straight in horizontal way only. And if there is any slantation on the text, say like if the text is being pulled like inside, just for example, if in a paper you write something, and if you are if you are smudging those paper, and if you open and if you pull it around the slant, if the text are being slant or pulled inside like some kind of stuff, that's called slant. For that slant we still don't have so much accurate detection, but it is able to detect if there is too much of a slant in that one. So you might wanna check it around and do some more experiment and do it around. But nonetheless, we are getting all whatever we are seeing on the Anuvaad's documentation, and uh, we have seen only tilted images, not the slant ones. Okay, slant ones you can take it on if there is any specific requirement is there. When pre-process API has been done, you can add these things: slantation detection, tilt correction. So by the way, this orientation correction is a naive approach, the method one approach. Method two approach using large east using the whole large east model. It is used in for which one? Anuvaad models for Ulka purpose. Ulka. So there is one repository called Tesseract Ulka version 2. So that large model east model is used in that particular uh, for that particular project, that service. Okay, so here you can read all this. Class 1. So first method we used was east model. Okay, within east we just saw that okay till up to 90 degree it was okay to detect and get that degrees, but rotating it to another angle was pretty much difficult. Only each model did not give such a good example. We can see this one, uh, angle of 4 degrees is been tilted up to 2.2 degrees. Okay, we have still 1.8 degree difference, but it's still not good enough. Okay, so that's why wherever we got more error at angles less than uh, 0 and greater than 0, to up to 2 degrees and up to zero point 0.5 degrees, we are just matching it around. And next comes the uh, which one? OpenCV based one. We tried that also. So implementing that, so we got straight approaches. But for this one, which one? Uh, Poorly class 3 kind of a document, this was a bad approach and it was taking huge amount of time. Okay, so it was taking a lot of time to even detect. Doing the orientation correction for this. So that's why this was also not a good case for us, and we got some drawbacks. That was a score based one. Okay, so next we integrated with one with east and one with how lines. Okay, where we extract lines from the text. OpenCV has how transform functionality, wherein it extracts how lines from detecting those straight lines. Wherever wordings are there, it will make one line. It will just pass one line and make it a straight line. We will see that line. We'll measure that line. If it is not straight, if it is not 180 degree, we will turn it up to 180 degree by force using east and Hall lines. First, we will fire east. East will give some up to one extent degree. Now, next I will fire up another one called Hall lines. How it is see? Hall line method is to give angle made by the line with origin as shown figure. See, if this is the line, the origin of the angle. So you have seen the, you have understood the, mathematics of that, getting the angle between the one line to another. So the same thing, our lines is the same thing. So here is one example. If, so the input image, is like slightly tilted, and the detected lines are these many. And for these, we have to figure it out in some way that we have to omit all these wrongly added lines. Like you are seeing some uh, X or some other lines are coming crossing across. It's not like that. So see that this one, another one is a clear image where lines are being detected properly. That's a good one. But the one in the first one is it's pretty much wrong and it's slightly tilted only. So you have to make it straight. So look at this. This is whole mess. So these lines are getting all over the images. So we need to isolate these potential horizontal lines to get one angle. Okay. So for this, what we will do, we will use low pass and high pass filter. Okay. The basic idea is to get the angle from east and whole lines. We'll get two lines. So empirically for each and every line, we added a margin value. Okay, one, see that if it is coming or not. No, it's not coming. Two, it's coming or not. No, it's not coming. So by doing that, we till up to margin value of 20, uh, 20 integer points, we tried to tilt. So we saw that at the empirical point of 9, no, 9 is just an integer number. Just keep it as statically. Okay, don't worry about that. So at point of 9, we got that it would rotate up to 0.2 to 0.5 degree, up to 1 degree it will rotate. Even 1 or 2 degrees also enough to capture OCR. That is good enough. More than one. You don't want to have perfect straight images. We can tilt it around. So by doing that, we made a low pass threshold, making that east angle minus margin, high pass threshold, east angle plus margin. And we got the angle. So saying that median of low pass threshold, which is less than how angle is fired already, the lines, whatever the angle it gives, and that is less than high pass threshold. What is the angle of that particular image needs to be tilted around. So for that angle, we will fire the OpenCV tilted one. We will make the tilt correction then and there itself, and it will be tilted around. See, up to target angle of 20 degree to minus 20 degree, I have checked and it's verified. For class 1 document, perfectly working fine. For class 2 document also, it's working perfectly fine. 0.5 to 0.5 to 1 degree. Class 3 has severe issues. I mean, there is too much of noise, too much of images, scattered lines. So you will get too many noises here. So we found out that okay, for class 3, we need separate thing. For that, we have approached another way using of a large amount of east model for tilt correction. In that OCR will come services. You can onboard in Anuvaad also. Since there was a constraint that there were too many large models and it will take too much of time consumption, so we did not onboard. You can onboard still now also. It won't take much of a time and you can do a tilt correction. If there is any possibility that you get these kind of documents or these kind of images, you can approach this one and make the images properly. I'm not talking about any OCR stuff or anything. Okay, you can make this image straight. You can clean this image, make it clear. Okay, a good image can get you a better outcome on the OCR side. Else you will suffer there. Okay, that's why. So this is where we get. See, I mean, these are the class 3 kind of images which will suffer. It will get you up to some extent, but it will suffer a huge amount. I mean, for handwritten things and all, this will not be a good case. The naive one. You need to use the east model wherein you have to read it properly. So these are just a success case of this thing. Okay. Now coming back. Now the now the reorientation angle is done. How exactly? So here in the reorient, we will get the angle. How you will get the angle? So we are getting the text difference. where is this getting from? Let me go from the top. Augmented data frame. I don't think this augmented data frame is required. Okay, nonetheless, let's see. See, we when using craft kind of approach. I mean, when you're using craft models, so you'll get all this height, width, the bounding box, etc., etc., etc. things, right? So you'll get in XY coordinates, you'll get the bounding boxes, you'll get the height and width, all these things. So for each and everything, you need that particular data frame. I mean, bounding box. You need that bounding box for the, I mean, for that line, texture line. So for that, you'll just make height, width, and the wide mid and the area of that particular line. How much exactly is that particular line based on that rectangular box? Just send it over. Okay. Line changes keep to 0 always. These are just external values. Don't worry about that too much. Okay. Getting the rotation angle. So first we get the texted DF bounding boxes. We augment that particular DF and we get the Y mid range. So now we will use that bounding box and get those lines x2 minus x1, one line, y2 minus one line. So for all the boxes, whatever we get, out of all these boxes, we'll get one x mean value and one y mean value, mean statistics. Getting it? Hmm?
Yeah.
Specify x-axis and x-axis 1, comma 0. Do a cosine plot. Hmm? Get this particular box directly, one x mean and y mean on this x-axis coordinate. Okay, 1, comma 0. Now apply this line algorithm, the whole line algorithm. Okay, this is just I'm using NP line algorithm, but use the whole line. Okay, after that NP across cosine into 180 degree. You need to add 180 degree circle, area of circle,
Ah.
pi into something is there, that one. Don't worry about the average height and width. At last, get the angle into NP sign of box of that particular, I mean, box director in the sense bounding box, whatever you're getting that dot format. In that, you'll get two things, as I said, in this particular area, x, y. Just select the first index. Okay. All the zeroth index will always be uh, somewhat it is 0 or more than less than 0. Select the first one. Okay, you'll get one angle. How will you rotate that? You already have this rotate function. Get the dimension of that particular images. Okay, image shape you need first. Okay, width and height. Getting it? Grab that matrix, rotation matrix. Clockwise you have to rotate. Get rotation matrix 2D. Cx and Cy you already got this. Width and height. Angle. Angle is where you are getting from this one. Hmm? And you specify 1.0 up to 1, not more than 1. Okay, now you got the rotation angle. Now specify the bounding dimensions of the image, cos theta, sin theta. Apply these things. Now after this, with CV2 wrap affine, after getting all this, compute the new bounding dimensions, adjust the rotation matrix for whatever the images what you're getting on. Perform rotation on this CV2 wrap affine, wherein I'm using intercubic and border replicate. Wherever you see if the border is being pulled out, you have to replicate the same thing to the rest of the image also. You don't want to leave that as plain or black. You just have to pull it out. So after that, replicate, the image will be rotated. So when this get rotation angle, whatever I said this no, when the angle is given greater than or equal to 2.5 degree, let's say like absolute, if the angle absolute angle is greater than 2.5 degree, then we will rotate. Okay,
Okay.
If it is not 2.5, we will not rotate. So we have found out that up to 2.5 degree OCR can be done. Any OCR, either TensorFlow, OCR, tesseract, yeah. Up to 2.5 degrees, images are fine. After 2.5, no, it's not good approach. Okay. So this is one orientation correction. So after orientation correction, get that particular text data, then pass on to doing tesseract, where it will check for watermarks again, and it will get the text and get the bounding boxes. The boxes are been extracted, lines have been extracted, regions are been done, regions are done, line extraction has done, and that's all. Lastly, output file will be extracted to the final one. If there is any mask images set to true, masking will be happening here. Okay. Using the bounding boxes, will mask that particular images, saying that if there is any image or a separator kind of thing, we'll say that those regions should be masked. We'll get the endpoint correction, where if there is any margins still inside an image where overlapping will happening sometimes, we'll just clear it out with this logic. Okay, that's all. This is 1.0. Hmm? Do you have still any questions on this 1.0? I'll show you this output. If you just pass this PDF, your output will be directly language will be English. It will be detected in this output pages. First one will be the image one, bounding boxes of that particular pages. Page number 0, region. First will be para, second will be line, and the third will be words. Getting it? Pinto?
Para line 1. Okay, this is what we were using for glossary extractions.
Yes. Even in the first one, we have something called as a symbol, another class called symbol, wherein you will be getting
brackets,
not brackets, and even single letter also, letter by letter by letter. It's not required, but it will be given. This is version 1. Okay. Now let's get back to version 2. Version 1.5, wherein the service is inside OCR folder, inside OCR GV server, or the functionality and the functional code, everything is same as whatever we are seeing in all the previous services. Inside services, process input. Next, if this is for JSON only, if the JSON is there, text extraction will happen. In the text extraction, first we'll get the page info, all the images info. If the font detection is set to true, I'll set the font properties. Else, currently the font property is being made none here in Google Vision. Just give me a moment, please.
There was one image.
Yeah.
Yes, sorry. Who is that?
Yeah, Ratan. You know something?
Oh, no. I couldn't hear you properly. I'm sorry.
No, were you able to?
Yeah. Walk through the thing, but I couldn't hear the last few sentences properly, by the way.
Okay, which one exactly?
Exactly the last few sentences. That is before I unmuted.
This one in
font.
font.
Let's go back. Yeah, the last part of the code. Yeah.
Okay.
Let me just.
Can you mute?
Sure.
See, okay, the OCR GB server service. So it's a replication of, I mean, replication, and it's written same as in whatever we have shown in GB document digitization. The code is same to same. The functionality is same to same. Just post processing approach is a little bit different here. Once we go into text extraction functionality, wherein we will be so this is basically coming from JSON files. So we'll have those JSON files and we'll have those image paths also. So say that here, if the font value is made to true, since block segmenter was not giving a good amount of outcome for fonts, so I have made say that if the fonts are being rendered, I mean, if it is made true in the config file, so I'll add the font properties as whatever the block segmenter is throwing it out. Else I'll be making the font info as none. I won't just pass the font info at all and just do the OCR and send it across. Okay. Now for each and every pages, so we have seen that we will require that identifier, and we will be having a resolution. I mean, each and every image resolution is set to 300 dpi. Okay, here it is statically given out, but when extracting image from in document GB document digitization or in word detector, so it is specified with respect to 300 dpi only, not 72 but 300 dpi. So the resolution of the image is 300 dpi. So after that, we will specify all the initialize all the regions. So if there are regions in the particular JSON file, or if there is any words or lines in the JSON file property, we will initialize those things, and we will add those coordinates for cropping those lines or cropping those paragraphs for the um, after cropping we will get the OCR on the particular crops and images. So for that, in the get text functionality requires lines, image path, the file name, and the directory, the dictionary where we are specifying the uh, block identifiers, regions, words, font info properties, and file properties, and which particular index you are sending on. Let's get into get text functionality. First, it will check for again the watermark approach. So if the watermark is there, it will create a watermark remover approach. Else, it will just make it as a plain old image path. That's all. After that, it will read the image and get the particular response. Once the image is giving out the this one OCR, all the OCR text and all the things, we will bound them onto whatever the bounding boxes in the classes we have specified under our layout or segmentation processes. So in get bounding boxes, we will specify the block regions, identifiers, and bounding box blocks and vertices. So with respect to paragraph, lines, and words, we will specify same functionality, nothing more different. Whatever we have seen in GB document digitization. So it will be like three-way around paragraphs, lines, and words. So here we will extract lines for each and every line, and each and every word we will have an identifier UID, and for that particular word where exactly it is situated for that bounding box. These bounding boxes are been added via where where are we getting from? These are being getting from Google Vision itself. We are not doing anything. And again, in those words, if there is any symbols around, we don't want to add those things also into the our files. So we'll just omit it, and we'll just collect it the symbol into word level. That's all. Okay. After that, for each and every word, we will be having a confidence score. We will be appending that confidence score also to JSONs. Okay. If there is any language is detected in that particular words, even the language is also being added there. So after all this, so say like, so this is the up to 199 page words the bounding box formations have been done and it's created. Say like if there is any craft line layout has been specified for this particular document. So like craft is being run for this document or a line layout detectron 2 is run for this particular document in the previous services, we will not have those particular line bounding boxes. Sorry, we will have those particular line bounding boxes here. We will not consider Google Vision bounding boxes, whatever it's giving. We'll consider the services which has been provided for that line, craft line or a line layout. We'll consider that one and we'll replace that these lines with uh, I mean those lines, whatever we have got in craft and line layout. Else we will specify Google Vision itself if these two configurations are not been added. Okay. Next, the same thing what we are doing, remove overlap of lines. If there is any overlap happening on these bounding boxes, the same functionality which we used in layout detector part. So the same code here also we are using the same thing. We will be updating the coordinates accordingly. So not more than that. Same functionality, same approaches. Text is extracted and now from get text we got the text and we made the bounding boxes also. We got the bounding documentation also. After that, if there is any font information should be added for those words, that also will be added. So how will be adding those things? See font. So we are specifying with respect to this is a custom logic wherein if there is no font info or if there is no font there, so we'll get the height and width of the particular word, whatever is there. We'll get the bounding boxes of uh, that particular word wherein the vertices of 0th index of y and the bounding box vertices of the last one, the y1 the y2 of the vertices, will take that and y1 minus y2 we will get one height. We'll get the page word wherever the index should be for that particular font. So currently we are specifying statically as Arial Unicode MS. The height, whatever it's rendering, what is the height of that particular font, we will be showing here in the font section. And currently we are keeping it as regular for UI purposes. So say that so if you are generating in a polygonal way, so there is already a function called polygon where you find these vertices. So you get the x and y points and you get the polygon function using simply and get the particular rectangular box. Through that, once again, after getting polygonal box, we'll insert the polygonal, the rectangular bounding boxes to uh, this particular bounding box vertices wherever we are specified in region operation. Okay, after that, so if there is any intersection or any bound, bold or superscript kind of things are detected on fonts, we will not omit all these things. We'll keep it and we'll retain it in the styles on the font area and we'll send it back. Okay, all these operations you have to go through each and everything line by line and then only you'll get to know. So I'm not explaining each and every piece of code line by line by line. I leave it up to you to understand. Okay, I'm saying whatever the functionality does that particular function do. So you have to go through all these things again and again. Okay. After that, you'll update those all the page words. So if you have seen in the each document, say like if this is the region, so in each and every word class you'll have the font information, confidence score, the font size, style, average size in the languages. These are being shown from this particular functionality. So we'll update the style and we'll do the region operation. So after that, next comes the segmentation. For segmentation, what we require? We require this page word also, and we require page lines also, regions. And if there is any craft words or craft lines or any other properties specified, what we'll do, we'll segment this region. So if there is a mask image is being made to false, we will not save any mask images. Else we'll read that image. If there is any craft particular thing line is there, or that is there, we'll use mask craft image. See the class, if there is image or other or separator or any table kind of structure in that particular masking area, we'll mask all these things. Even the table structure, we'll mask it to what, 255. These things, I think Pinto is making another
It's also similar to the other ones that you know.
yeah, same thing. So Pinto is refactoring this masking. It has some issues where it is taking too much time to mask images. Okay, so I think you can connect Pinto what he has done, and he will give you those approaches whatever he is doing. If there is any noises in the background, it will remove noises. So I think these things also, these noises, and this Pinto is only added. You can approach him and you can ask him on that. And set image is done. We are getting in the get text, document bonds, set region. Now we got the uh, this one, segmentation list, the page words, and if there is any save path for that maskings. Okay, we got all these things. The JSON is now enriched. Only the dictionary JSON is enriched, not all the complete JSON. Okay, per page, page by page by page, it's being enriched. Okay, this text section. Okay, now if there is background images, we'll set the background images, saying that identifier background image base 64 we are not using. Background image, if there is any path we are getting, we are using that one. Page output, in page output we'll get the background image, we'll set that. Now next, so due to Google Vision, it was consuming a huge amount of time to process a large amount of, let's say like 100 to 200 pages. It was consuming too much amount of time, and too much of memory usage also. So it was consuming, so where each container would crash, and it would, the server initially, I mean, it would stop and it will switch off itself. It will show that out of memory, and CPU will be at peak, and it will switch off. So for that, what we did, we are using temporarily output storage as Redis. So say like, if per page, if it is done, we will be storing the whole output structure to Redis DB temporarily, until and unless this particular job is done. So we'll be storing it to Redis DB. Once all the pages have been done, what we'll do, we'll get those keys again, we'll make a JSON, we'll delete it off. Nothing more than that. See, like how we are doing it, we are doing it in the same way what we were doing in content handler saving hashes. So there, it's like languages, sentence, user ID. So here we are getting it via image name. So I'll get the image name from the image path, whatever we are getting from. I do a shaft 256 image hash. Okay, then save it in the Redis DB. Where did it go? Oh, save it in the Redis DB in the JSON format. Currently, DB number 7 is used for OCR GB server Redis DB. Okay, we'll save them. I'll just append those Redis keys, image names, Redis keys to sentences. I mean, append to one list called Redis key. I need those names. Okay. So after this, I'll I'll delete that page output. for each and every page, whatever I've got now, I'll delete those page output to release that memory issue. Okay. After this thing, so post processing everything is done. So after that, I'll call the Redis server again. I'll get that. I'll load that particular JSON output. If there is any file properties to be added or any regions to be deleted, I'll delete it off. Again, the font is made to true. I'll here for some reason the font is being made to false. We'll check it afterwards. So then again we will delete all the Redis keys once these values have been loaded and loaded and taken out and made to JSON files. After this is done, we'll just send it to our tokenizer service, wherein tokenizer checks for text and tokenizes the sentences by sentence. Okay, this is what Google Vision is. Okay, Google Vision 1.5. Okay. Now tell me if you guys have any doubts in 1.0 Google Vision and 1.5 Google Vision services. So currently the Google Vision accounts have been used. I mean, they're planning to close and they're planning to deprecate. If you want to use for your cause and yourself, I mean, for experimental purpose, you can use it your accounts itself. Okay. You can create it and you can use it. And if you want to integrate in dev and check it on, you can check it on. But make sure of your limit that it should not cross whatever the 150 million sentences it has specified for your cost, whatever it is. Okay, so that you won't be charged moving further. I mean, if you want to use just in the developer's environment, you can ask the leads and take permission and uh, experiment it on. Okay. So that would be enough. So yeah, if you guys have any questions around Google Visions, you can ask me now.
Check the code and we'll process it. None particular issue. We can go ahead.
You can go ahead now. Okay, then I'll start with the Tesseract one also. Okay, you guys have time now. You guys have time, still time, right? Windows
Yes. Yes, no problem.
I think Ratan got a message from Marvin for a quick call.
Yeah, I pinged him on that. No worries.
Because today is the deadline. I want to finish it off all the KTs. That's why I'm in a hurry. Okay, let's continue with Tesseract OCR also.
You can make this recording and you can start a new one. Google Vision separate.
Yeah, I'll do it. Let me just stop the recording.